The roots of quadratics, which are also the zeros, which are also the x-intercepts. These all mean the same thing. These all mean where the quadratic crosses the x-axis. No.
I feel like math is more important.
Just like reading.
Get your phone off your desk. Stop sucking up.
I don't like it. My pockets are small. Hey,
Your backpack's a good place for it.
Just as if all your pocket is giant.
Okay, so the names 0, x-intercepts, and roots all mean where the quadratic is crossing the x-axis. And we are going to be able to find those today. We are going to be able to find those today.
Doesn't 0 have, isn't it Z-E-R-O-E-S? Or is it just S?
Oh, I don't know. I can't spell. Maybe.
Yes.
It's possible.
Oh, no. That says S, so.
I'm going to assume that was spell check too. So, okay, guys. So, roots are the solutions of the polynomial equation. Zeros are an x value of the quadratic function where f of x equals 0. This means, basically, y equals 0. And that makes sense because when y equals 0, you are on the x-axis. So, when y equals 0, you are on the x-axis. So where would you be if x is 0? The y-axis. So if you ever need to find the y-intercepts or the x-intercepts, you just make the opposite variable 0. Intercepts are where an equation crosses the x or y-axis. So if it is an x-intercept, it is where it crosses the x-axis. If it is a y-intercept, it is where it's crossing the y-axis. So go ahead and flip to the next page when you are ready. Come on, Josh.
Josh.
Lane. Say something again.
Okay, guys, let's focus. Guys, please focus. Okay, guys, please stop talking. Okay, so we are going to answer this. What are the zeros of this function? Where is it crossing the x-axis? So what are my zeros of this function?
-8 and -2.
-8, 0, and -2, 0.
I drew it.
It is where we are crossing the x-axis. It's when y is 0. What are the roots of the function below there? When is it going to cross the x-axis? Never. So you will learn this later in Algebra 2, but they are imaginary. Also known as no real roots. This is when the graph does not touch the x-axis. So when the parabola does not touch the x-axis. Yes.
Parabola.
Okay, so what if it doesn't say roots? What if it says zeros? Would you put imaginary zeros? Or
You could still say roots. They all mean the same thing. Guys, please stop.
Yeah.
Can we please Stop. All right, questions so far before we go on to the next slide?
Wait, can you go back?
Yes. That's your pen.
Yeah. It's not really my business.
Okay. State the x-intercepts. So state the x-intercepts. So you'll notice there's two. It's not at an exact point. Do you guys see that? So there's two ways you can write this up, and I'll accept both answers. You could say it's between -2 and -1 and 3 and 4. Or you can use an interval, which isn't a bad thing to know how to do. So an interval looks kind of like an ordered pair, but it just gives you the two values as a like the between. So it goes from least to greatest, so -2 to -1, or that's what that U stands for, 3 to 4. It's a union, which is an or statement here. So that just means or. I do not care which way you want to write those up. But if it's between points, you can either just say between the two x values, or you can use the interval notation.
No. Give it to me.
Don't go to him.
Give it to
You
me.
gave your food to her yesterday.
Guys, stop. Connor, what's up?
Okay, this might be a dumb question.
No, it's not. What's going on?
That's debatable. But, so, wait, I answered my own question.
Are you sure?
Yeah.
Okay, guys. So make sure you guys understand both of these, because we could write this up either way on a test or a quiz.
Wait, I have
The interval notation is much actually simpler. It's cleaner to write it up this way, so I'd prefer you guys to do it this way. But this is another way you can do it if that does not make complete sense to you. Yes.
Okay, now there's kind of stupid questions. Those are like things you circle called the zeros, right?
Uh-huh.
Okay.
Or the roots, or the x-intercepts.
There's one more, so I might as well.
Okay, so this one tells you to state the vertex. So Alyssa, what is my vertex of this graph here? What is it, in this situation, what can we also call the vertex?
Zero.
It's a 0, or a
Zero.
root, or a x-intercept. They're all of those things. So, just as a side note, you typically will have two roots, or zeros, or x-intercepts, unless there's two situations. The parabola never crosses the x-axis, and that means there's imaginary solutions, or no real roots. Or the vertex is on the x-intercept, or is on the x. One second. Then you only have one root. What's your question?
I was saying, so it would.
So you will have.
It would be one root if it touches the x and
So it will always have. It will almost always have two roots, unless it's sitting on the vertex is sitting on there. Then it will only have one. Or like the situation we had on the previous slide where it was never touching, will be imaginary. Does that make sense?
Yeah.
Okay. Yeah.
So for the vertex one, would it only work for minimum? If it's a minimum?
No, because the maximum can open down. So like if we did that, the vertex is sitting on. Okay, when you are ready, flip to the next page so I know you are there.
Alright. We got 4 more slides. That was easy killing it. What are you gonna do?
Next slide. Shh. This one asks for the x and y intercepts. Who remembers when the equation is given to you where the x or the y intercept is? Who remembers where the y intercept is in the equation from yesterday?
End of the equation.
Is that what you were going to say, Connor? Okay. It is. It's the last number here is the y-intercept. So if you're given the equation, that is your y-intercept. So just so you guys are aware, we're looking for the x-intercepts. It might be 2. Or the y-intercept, which will only be 1. So our y-intercept is at 2, 0. So we are on the y. Oops, I did that wrong. That's 0, 2. So when you are on the y-axis, x is 0. So that's why it's 0, 2. When you are on the x-axis, y is 0. For the y-intercepts, we are between values here. For the x-intercepts, we are between values. We are between 0 and 1, so you go least to greatest. And we are between 3 and 4. Okay, I'm going to make a note here. These are not ordered pairs. These mean between 0 and 1 and 3 and 4. So if you want to state what they mean so you know how to read that later, it might be smart. So besides RC, because you are here.
No, this is
No. Who sits here?
Me, Kaylee.
Haley usually sits here. So Connor Clover's not here. Okay.
latest year she
All right.
eat everything.
Guys, please stop. So first tell me now, we need to state the vertex and tell me if it's a max or a min. So Jordan Fields, is that what is my vertex? Good, that is your vertex, and is that a max or a min, Jordan? What? It is a minimum. It is the lowest point on our graph. Yes. Are you done?
Yeah.
What's your question?
I'm just double checking again. So the vertex of the hash lowest point on the graph.
Yes.
Okay, I'm good.
Thank you.
You're welcome. So, this asks you for the zeros. So, the zeros are also known as your roots or your x-intercepts.
There's 3 zeros.
So let's stop for a second here, please. If we're looking for an x-intercept, which value would be 0?
Why?
So, we look for when y equals 0. So y is 0 here and here. It is not asking for a y-intercept, it's asking for an x-intercept when it says zeros. So my zeros are at -1, 0, and 1, 0.
So zeros just mean x-intercept?
Yes. It means roots, zeros, and x-intercept all mean the same thing. Okay, so the next question here says state the line of symmetry. So to state the line of symmetry, we have to know where the vertex is at. So, Blaine, where is my vertex in this problem? So let's start there. Where is my vertex?
0, 1.
So my vertex is in the center of the line of symmetry. It is my highest or lowest point. In this case, it is my highest point, which makes it a maximum. So I have a vertex at 0, 1. So when I go to write my line of symmetry, my axis of symmetry, however you want to name that, what would my line of symmetry be then, Mike? What is the line of symmetry if my vertex is 0, 1? It's always what kind of an equation? Because it's a vertical line, it's always going to be a... Thanks, guys. I'm talking to Mike, though. So it's x equals... No, it's the x coordinate of the vertex because you're saying what x equals. So it would be x equals 0. You of all people. Interrupting my 7th hour yesterday.
Yeah, I'm coming back today.
I'm sure you are. No. I kicked Justin out yesterday, so.
Can I really come back to you? Yeah, we only have to. You can only deal with us for an hour.
All right.
No, Miss Brown.
Yeah.
I didn't follow that.
Okay. What are my zeros? So remember, the zeros are when you're looking for the x-intercept, which is when y equals 0. So when does y equal 0? At negative 1, 0. We typically have 2. Is that my vertex? Is negative 1, 0 my vertex?
No.
Is there symmetry around that?
Yeah, it is the vertex.
It is. It's 1 and 1. You were right. You were right.
I was right.
So 1 is symmetrical around here. So we will only have 1, 0 when it is the vertex. So this case, it's negative 1, 0, which happens to be our vertex. Because of that, we know what our vertex is already. So Cassie, what is the line or the axis of symmetry? As an equation. Look up. Well, you didn't write it up there when I did it. You got it, Kaylee?
I think
Go ahead.
x equals negative.
It is x equals negative 1. It's x equals the x coordinate of the vertex because the line of symmetry is a vertical line. Please stop. Okay. Josh, do you think this graph has a maximum or a minimum? Yeah, if you look at these numbers on the y, you look at the y coordinate of the vertex. Is that the smallest y value or the largest y value? Smallest, so it is a
Minimum.
And explain my answer. The y coordinate of the vertex is the smallest y value of.
That was tired.
All right, Riley.
Yes.
Next table there. What are my roots or my zeros or my x-intercepts?
0, 1.
It's when y is 0, because roots are when it's the x-axis.
But
So
there's no 0.
okay, so he's claiming that there's no 0 in this table. If we were to
On the y.
you're right. If we were to continue this table, would we ever get to 0?
No.
No, if you look here, going towards the vertex, it is decreasing. Do you guys see that?
Yeah.
But is it
Going away from the vertex, it is increasing. So will it ever decrease past 1?
No.
No. So will we ever have roots then?
No.
No. So what do we call it then? Imaginary
imagine?
or no real roots. What?
So it's only the roots when y equals 0? Because like that's kind of confusing me because you always write when y equals 0, but what do you do if you define the x?
That's the y-intercept. If x is 0, then you're finding the y-intercept. Okay, because you're like, do you see how you have it moved left to right then? Okay. What is my vertex, Grace?
0, 1.
So here's another way to determine the vertex is kind of look for those increasing and decreasing intervals. So if you see here, it's decreasing to 0 and then it's increasing again. Do you guys see that?
Mm-hmm.
So it will be increasing or decreasing towards and then doing the opposite the other way. So that's another way besides looking for that symmetry. State two solutions. So two solutions are any points on the parabola. Go ahead.
2, 5, and negative 2, 5.
Yes, 2, 5
That was it.
and negative 2, 5.
Nice one.
Oh,
Any of them are fine. Tanari, is this graph going to be a maximum or a minimum? It is a minimum. 1 is the smallest value there. You also know it's a minimum because it goes from decreasing to increasing. So it's creating, do you guys see if you go from decreasing to increasing, it's going like this, so it's creating a U that's down. So if you're going increasing to decreasing, do you see how it creates an upwards? So that would be a max. So that's another way, because you could say because the parabola goes from
You make it sound smart. Meanwhile, I'm over here writing 1 is small and it's vertex.
that's fine.
1 is small and it's vertex.
I do not care which way you do it. I'm just giving you guys two different things here. Do you guys see that? I'm trying to show you guys different ways because maybe it didn't make sense to you what I said before. Connor.
So if it's minimum, if the vertex is the lowest number.
If the y coordinate of the vertex is the smallest y value, yes.
Okay. So let's say the vertex on the second one was like 7, then it would be a maximum.
No, because it would have to be a completely different table because it would have to be going from increasing to decreasing for that to happen. So like if I gave you one second. 0, 1, 2. No, I don't want to do 0, 1, 2. Okay. If I were to give you this one, do you see how this one is increasing to decreasing? So increasing to decreasing creates a maximum. Also, this is the highest value. Do you see how 0 is bigger than any of the negatives? Do you see how that's different? Okay. All right, guys. State the y-intercept. State the y-intercept, which is when x equals
0.
0. So it's when x equals 0. So when does x equal 0, Alyssa? When is x 0?
Never.
Yes, it is.
I did this.
1.
No, 0, 1. So x is 0 at 0, 1. So the vertex is actually on the y-axis this time. Okay, look at those and see what questions you have before we do a couple more.
Can we skip the next one? Go last.
No.
Why?
I already did this one. So you
Okay, x and y intercepts. An x-intercept is when
Y equals 0.
an y-intercept is when
X equals 0.
Whoa!
it's the opposite variable. X you could have 2, so you have to be careful when it's a parabola. So just be careful there.
How do you just naturally write parentheses? I can't write parentheses unless I literally force myself.
Okay, guys, the x-intercepts. I don't know, sorry. I just do. It's just like a curve. It's like a C.
I feel like it's because she's a math teacher. She's been writing for so long.
I don't know. I also don't.
Like,
It's a C.
I can't make a parentheses without it make it look like it's
I see.
and then, like, a sad face.
Let's start with the y-intercepts because those are easier. When is x 0? At -3, we have a y-intercept. So this is 0, -3. No. I don't care. Guys, when is y 0?
Never.
But could it be 0 at some point?
No.
No.
Could be.
Wait.
let's look at this
maybe.
here, guys.
Yes.
So, this is my vertex. Do you guys see why this is my vertex?
Yeah.
No. Yeah. It's the lowest number.
It's the lowest number, and we have the repetition around it, right? So, if I'm doing this, it's lowest number, then it goes -6, so it's getting bigger, -3, and then all of a sudden it's positive.
Whoa.
So, will it cross the x-axis?
Yeah.
Maybe.
Yes, it will. When?
And between
-4 and -5.
4 and 5, -4 and -5,
Okay, when x is -4, -5, and?
-0 and 1.
So, our x-intercepts are going to be the interval -5, comma -4, u, 0, 1. Okay, as a reminder, these are not
Ordered pair.
ordered pairs.
Why is it a U and not literally anything else?
It means a union, so you're putting the two things together.
Like so.
So it means between -5 and -4, and 0 and 1. So I don't care if you guys decide to write it as just between those values or you use the intervals. Just understand that the intervals are not ordered pairs.
So, never mind.
You sure?
Yeah.
So.
Never mind.
Never mind. I can't make the U without the little like. I can't do it.
Ryan, where is my vertex? It's not symmetrical over that. Be careful. Where is it symmetrical over? Which value on the y is there repeating numbers around? Look at the numbers. Do we see any repetition of numbers on the y here? Just look at the y values. So -3 repeats and -6 repeats. Is that what you're saying? So where's my vertex then? There you go. So our vertex is at -2, -7. What is my equation of my line of symmetry or my axis of symmetry then, Jack? Does this graph have a min or a max?
Mine.
It's been a min every time. If you want to look at it from increasing and decreasing intervals, it is decreasing to increasing. So if you think decreasing to increasing, that creates that scoop, and that's why. Or -7 is the smallest y value.
That 2 ink or 7 is small.
Stop pulling.
What?
Sorry, decreasing to increasing, if that makes you happier.
That's weird.
Okay, one more slide. I think we would have been done with this whole entire note packet if you guys would not talk over me the whole time. Just throwing that out there.
Okay.
Go ahead.
I don't know if I already asked this, but like, why is on the line of symmetry, why is it next? So maybe a super question.
It's a y, it's a vertical line. So like if you're thinking of a parabola, it's going to go up and down every time, so it's crossing the x-axis, which is an x equals
What
equation.
if it was?
It's not going to be sideways because that's not a quadratic anymore, so that doesn't matter for this.
I think I already asked that question.
Yeah, they don't go sideways because the inverse of a parabola goes sideways, which is a square root function. So, but you guys aren't learning that this year, so don't worry about that. Okay, this is a very long paragraph, so I'm going to read you a story. The International Space Agency has finally landed a robotic explorer on an extrasolar planet. Some probes are extended from the lander's body to conduct various tests. To demonstrate the crushing weight of gravity on this planet, the lander's camera is aimed at a port, and the port launches a baseball directly upwards in an approximate speed of a professional pitcher. The equation of the ball is modeled by h of x equals -49x squared plus 145 7x, where x is the number of seconds and h of x is the total height in meters. So this is the number of seconds and this is the height in meters, so I know that. What is my y-intercept for this one?
140.
0. There's nothing added at the end. So we actually have a y-intercept of 0, 0 here. So what are the intercepts and what do they mean contextually? Well, we just said that our y-intercept is at 0, 0. So this means that it's also an x-intercept because y is 0. So that's one of our y-intercept, x-intercepts. What's our other x-intercept? Confusingly enough, this is a x-intercept and a y-intercept, but we also have another x-intercept down here. So our 0, 0s mean the starting height, I just spelled starting wrong, of the ball is 0 meters. The other x-intercept is 3, 0, which means after 3 seconds, the ball hits the ground.
The 0 and the 0 look like a face.
Okay, what questions do you have? Because that's a lot of information at once there.
I gave them bodies on my note.
Oh my goodness, stop. Okay, so this then asks you, is this a max or a min? Well, just think about what's happening. It's being launched upwards and then coming down. So that is definitely a max. But we can also look for our vertex in this problem. So before I answer the max or min question, where is my vertex at, Riley?
1.5.
So it's at 1.5, comma.
110.25. Yeah.
So that is a max because 110.25 is my biggest number. You'll also see it's increasing and then decreasing away. So if it's increasing and then decreasing, it is creating a maximum. So this means after 1.5 seconds, the ball is 110.25 meters. State the equation of the line of symmetry. Jordan Coward, what is the equation for the line of symmetry? X equals? It's x equals the x coordinate of the vertex. So what's my x coordinate of my vertex? Yeah, here you go. All right, so